Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of complex numbers, and the question is asking us to find out here that what is the fourth root of unity. So we have to basically find out the fourth roots of unity in this question. So that is the question asked to us. Let's figure out how to find the fourth roots of unity that are present. Before starting off with the solution of this question, I'd first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos for you on everyday basis. Let's first understand the concept of nth root of unity, and then we'll begin with the question. So if you know this concept of nth root of unity, you can directly jump to the solution of the question that is present. Otherwise, you can see this nth root of unity and then we'll take the question which is given to us. So basically, nth root of unity, we know it is a complex number which is raised to a power n. So let's say I have my complex number as z, and z is nothing but nth root of unity. So unity is 1 and nth root is 1 over n. So if I take that power n to the other side, becomes basically z raised to n is equal to 1. So that is your idea here. Now further, if I try to find out, I have to figure out this value of z here. So I can see that z, we know it is basically 1 raised to 1 over n, or I can just write z raised to n is equal to 1. So here if I see z raised to n which is equal to 1, I can write that 1 in the polar form. Polar form means basically in the terms of complex number as cos theta plus I sin theta. If I want to write it in the polar form, I can write this as cos. There is no term of I, so real part I can write just that as cos of 0, because real part is in terms of cos, plus I. Here I can write that as sine of 0. So I can write z raised to n as cos 0 plus I sine 0 in the polar form. Now further, if I want to write it in the general terms in terms of 2 pi, I know after every angle of 360 degrees, that is after every one revolution, you have that same value of cos and sine repeated. So basically I can write this as z raised to n is equal to cos of 0 plus 2k pi plus I sine of 2k, 0 plus 2k, because after every angle of 2 pi it is having the same values repeated. So this is the idea, and where we know that k, it's basically an integer. So k is any integer that is present. So I have z raised to n as like this. Now I have z raised to n is equal to cos of 2k pi plus I sine of 2k pi, the whole raised to. So whole raised to, if I want to write it in terms of whole raised to something, I'll just take that n on the other side. So from here I get my complex number that is basically nth root of unity which was given to us. So it becomes cos of 2k pi plus I sine 2k pi raised to 1 over n. Now if I use the idea of de Moivre's theorem, I know that says if I have cos theta plus I sine theta, I can just write that as e raised to I theta. So if I use that idea to write my value of z here, let's see what I get. So if I write that, z basically becomes e raised to I 2k pi raised to 1 over n. So when I have this 2k pi raised to 1 over n, it gets basically multiplied with that. So my powers get multiplied and I get z is equal to e raised to I 2k pi divided by n. And when it is 2k pi divided by n, I can just write that z as cos of 2k pi divided by n plus I sine 2k pi divided by n. So that z is nothing but my nth root of unity, which was 1 raised to 1 over. So nth root of unity, it's given to us by this idea, the cos of 2k pi by n plus I sine 2k pi by n, where k can hold all the values starting from 0 till n minus 1, right? So that is the idea that we have to use to find the fourth root of unity which is asked to us in the question. So let's find the fourth roots of unity. So if I want to find the four roots of unity, I know instead of n, I will have here 4. So 4 minus 1 will be the values of k that will be holding. So k can take the values from 0, 1, 2, and 3. So let's see how to solve this question further. So I know four roots of unity that I have to find out. For that, z raised to 4, it's basically cos of 0 plus 2k pi plus I sine of 0 plus 2k pi. Or I can directly use the idea that z is basically e raised to I 2k pi divided by 4. Here in this case, instead of n, I'm writing 4 directly. So you get this as cos of 2k pi over 4 plus I sine of 2k pi over 4, where k can hold the values going from 0 to 3. So let's put all the values of k one by one and let's find the different values of z that I get. So let's see. So here I get the k values. I can put 0, 1, 2, and 3. And from there, I'll get the different values of z. Let's figure out what are the values of z. So z basically becomes cos of, if I put k here 0, becomes cos 0 plus I sine 0. So one root I get cos 0 plus I sine 0. And cos 0 is 1, I into 0, which is 0. So you get this one root, that is 1. If I put k as 1, I get cos of 2 pi by 4. So cos of 2 pi over 4 means cos of pi over 2 plus I sine is also pi over 2. So from here I get cos of pi over 2 which is 0 and I sine pi over 2 which is 1. So you get I here. Next I get z equals to cos of 2k pi. So k I'm putting here 2. So 2 into 2 pi divided by 4 plus I sine 2 into 2, so that is basically again 4 pi divided by 4. So from here I get cos pi plus I sine pi. So cos pi is minus 1 and sine pi is 0. So this becomes minus 1 plus 0, which is minus 1. And if I put 3, cos of 2 into 3 pi divided by 4, so that gives you cos of 3 pi over 2 plus I sine 3 pi over 2. So that gives you cos of 3 pi over 2, which is basically again 0, and sine of 3 pi over 2, which is minus 1. So that gives you minus. So solving this and putting all the four values of k, I've got four roots of unity, and those four roots of unity that were asked to us are 1, I, minus 1, minus 1. So these are my four roots of unity that were asked to us. I hope you have understood how to solve this question. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share these videos with your friends also who are involved in the preparation of questions on JEE. So they can also take the benefit from these questions which we are solving on everyday basis. Thank you.